All right, we're returning to this length of life of light bulbs example. Um, so recall that we already created a confidence interval for this. So that was on this first slide. But I copied those results over here just so we could see them. And we had a confidence interval for the average length of life between 49,396 and 49,884 hours. But let's actually do a hypothesis test. So I've got another table here that's kind of like a template for what we're doing. And you'll be able to just use these templates so that you can just fill them out for yourself rather than like create these by scratch. So here's our question. At the alpha equal 0.05 level of significance, can we conclude that the mean light bulb length is different from 50,000 hours? Okay, so let's just take this step by step. So step one, we want to create our hypotheses. So our null hypothesis would be that mu is equal to 50,000, right? Because we're interested in whether it's different. If it's different, then this is a two-sided test. So that means our alternative hypothesis will be not equal to. So I'm going to use insert symbol not equal to 50,000. Okay. So what's our null value here? Well, it's just whatever the hypothesized value is. So this is going to be 50,000. Is this a one-sided or a two-sided test? Well, our hypotheses are equal to and not equal to, so we're interested in values greater or below 50,000. So this is going to be two-sided. Now for our level of significance, so for alpha, so our alpha here is 0.05. N, so N, I'm going to use equals count, and I'm just going to count up the number of points we had. We have 80, just like we did over here. Okay, so determining the sampling distribution, so checking our assumptions. Is N bigger than or equal to 30? Well, we can use a function here that I wrote up. And that is just, the function did not carry over. Give me one moment. So we're just going to use an if-then statement. So we're saying if D10, so that needs to change to D14. Okay, this isn't really working out. So here, let's do this from scratch. Let's say equals if, so let's say if N is less than 30, then we'll say, is N bigger than 30? No. Otherwise, we will say yes. Okay, so this is correct. So let's go ahead and copy this formula over here. Okay, so if our N is less than 30, this is going to say no, otherwise it's going to say yes. So this is working as intended. So because N is bigger than 80, this will say yes. So is the sampling distribution approximately normal or symmetric? So we can create a histogram or a box plot of the data. So let's do that real quick. Let's just quickly highlight our data. Do insert. Come over here. Remember, histogram is this button. We want histogram. And we can see that this very much looks symmetric, so I'll just quickly give it a title. So histogram of light bulb life. And then we can quickly just give it a title. So this is time in hours. And then this is frequency. So we can see that this looks symmetric because, or this looks normal, right? We can kind of imagine a bell curve on top of this, and it very much looks symmetric and centered close to the mean. So this is a reasonable assumption. So is this symmetric? Let's just say yes. Okay, so calculating our test statistics, we need to get our sample mean. We already did this in the first tab, but let's go ahead and do it again. So let's just get the average of our data. And then we can get our standard deviation again. So equals at standard dev dot s of the data. Okay, standard error. Recall that that was our standard deviation divided by the square root of n. So we're going to do equals standard deviation divided by square root of n. Okay, so 122. Again, we've already done all of this over here. We're just doing this again. Okay, t-statistic. Recall that our t-statistic is x minus the mean divided by the standard deviation. So let's just go ahead and code that. So equals. So what is our sample mean? So we're going to take our sample mean, subtract off the hypothesized value, 50,000, and then we're going to divide by our standard error, 122.6. And we're going to need to put some parentheses around these, right there and right there. Okay, and we get a value of negative 2.94. So let me go ahead and show these formulas. Okay, this all looks good. Not sure why some of these formulas aren't showing, so let's just go ahead, copy this over. So E20, so that is the mean, minus E10, which is our hypothesized value, divided by E22, which is our standard error. Okay, calculating the p-value. So is this a one-sided or a two-sided test? So this is one-sided, right? We decided that up here. So we're not worried about one-sided for right now. So for this, we're going to use a function called t.dist. So equals t.dist, and then go down to rt at the bottom. And then we're going to do the absolute value of our test statistic, which is t-stat, close parenthesis, and then comma, degrees of freedom, so that's going to be 80 minus 1, close parenthesis, and enter. And actually, I made a mistake here. That was the formula for one-sided. So let's try this again. Equals t.dist. We actually want the dot 2t, so dot 2t. So we want absolute value of our test statistic, and then n minus 1 degrees of freedom, so 80 minus 1, and enter. Okay. So this is the formula we're going to use. And again, if this is confusing, that's fine. Because this template exists, if you can just determine whether to use the one-sided or two-sided, all of these things can just be automatically calculated. I'll have a template available so that you can just simply plug numbers in, and it'll give you the, like you won't have to type this out directly. Okay, so p-value. So we reject if the p-value is less than alpha, right? So we're going to say equals if, so p-value is bigger than alpha, then we're going to say no, otherwise yes. and here I even have the sum, just to make this a little bit more general. But okay, so basically if our p-value here is less than our alpha here, then it's going to reject. And so let's have another conditional statement. So equals if this is equal to yes, then reject null, otherwise fail to reject. And let's go ahead and show off that formula. Okay, there we go. So, interpretation, we would say we have enough evidence to conclude that the mean light bulb life is different from 50,000 hours at the alpha equals 0.05 level of significance. And then we can just say, note that 50,000 is not in the 95% confidence interval. And so we could have determined that we would reject before we got started, because if we come back over here to our confidence interval, we see that 50,000 is not in the interval, therefore it is not a reasonable value. Okay, and that's how we can go ahead and just do a hypothesis test using this table. And again, I'll have this template available so that you can just go ahead and plug in the new values and it'll automatically populate this for you. And we'll do another example in the next video to highlight that.